Hello everyone, welcome to whisker Academy. In this video we're going to discuss more about quantitative data. This episode is going to be about displaying and describing quantitative data. If you're following my channel, you must have seen there is another video where I gave you some basic introduction of statistics, like what are the different data types. We discussed about quantitative data and qualitative data. So today we're going to focus on the details of quantitative data analysis and qualitative data analysis. These are some basic statistics skills you need to know about if you are aiming for a data analyst or a data scientist role. So let's start. So today we are going to discuss about basics of quantitative data analysis, so basics of quant. So first let's understand descriptive stats. So in descriptive statistics we usually look at three major type of analysis. So the first one is measure of central tendency. Then the number two is measure of dispersion, and the third one is measure of shape. So measure of central tendency is all about finding some common theme around the data. So it is a statistical metric that is used to identify the center or the typical value of a data set. The most common measures in measure of central tendency are mean, median, and mode. Okay, so mean value is equal to sum of values divided by number of values. Okay, so let's say we have a data set X with values as like 4, 8, 6, 5, 3, 4, 8, 7, 5, 4. Okay, now mean will be calculated as 4 plus 8 plus 6 plus 5 plus 3 plus 4 plus 8 plus 7 plus 5 plus 4 divided by number of values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the mean value would be 5.4. Okay, similarly we can calculate median. Median is always the value in the middle. Median is the value in the middle. For that we have to sort the data set. We have to sort the data set in ascending or descending order, it does not matter, but we have to sort the data set first. So in our case, in this data set, when we sort the data, it will be 3, 4, 4, 4, another 4, and then 5, 5, 6, 7, 8, and 8. So in this case, we have like 10 data points. So here, there are 10 data points. There are 10 points. Okay. So if the number of data points is even, the median is the average of the middle 2 points. Average of the middle 2 points. So average of 5 and 5, which is equal to 5. But in case we have a data set, let's say 1, 2, 3, 4, 5. So in this case, the median value would be 3, because 3 is in the middle. Okay, now in mode is the data point that occurs the most number of times in the data set. So in our case 4 will be the mode. So in this case 3, 4, 4, 4 and 5, 5, 6, 7, 8 and 8. In this case 4 appears 3 times. So in this case the mode will be 4. Then let's discuss about range. Okay, so range is a measure of dispersion. So range is the difference between the maximum value and the minimum value. So in our case, the maximum value is in our case the maximum value is 8 and the minimum value is equal to 3. So range will be 8 minus 3 is equal to 5. This is the range of my data set. The minimum value is 3, the maximum value is 8. So let's talk about variance. So variance is a statistical measure that quantifies the degree of spread or dispersion in the data set. So let's say we have a data set which is, let's say 2 1 2 2 3 3 3 4 2 3 5 6 7 7 3. Okay, now if we visualize this data on a number line, so let's say this is 1 2 3 4 5 6 7 8 9. Okay, so we have 1 here, we have 1, then how many 2s we have? We have 1 2 3, so we have 1 here, we have 2 2 and 2. How many 3s we have? 1 2 3 4 5, so we have 3 3 3 3 3. We have 1 4, we have 1 5, we have 1 6, we have 2 7. Okay, now if we calculate the mean of this data set, it will come somewhere here, right? So we use the variance to understand how much the data points vary from the mean. So we use the variance to understand the variance of the data points from the mean, or how far these data points are from the mean. This is what is variance essentially mean. So variance is a statistical measure that quantifies the degree of spread or dispersion in a data set. Variance is calculated as the average of the squared difference between each data point and the mean of the data set. So if I have so let's go back to our previous data set. So in our previous data set, which is 4 8 6 5 3 4 8 7 5 and 4, our variance would be, the mean value we knew that 5.4. okay, so our variance would be 4 minus 5.4 square plus 8 minus 5.4 square plus 4 minus 5.4 square divided by 10. So this one we can write as a formula, which is variance is equal to 1 divided by 10 and the sum of xi minus mu. Mu is the mean value, a square. So in this case, if you do all the calculation, this will come as 3.84. Now then standard deviation. Standard deviation is a different form of variance. So standard deviation is the square root of variance. Okay, so that's standard deviation. So in this case, standard deviation would be 3.84 square root. This value will be 1.96. Okay, so the next one is IQR, or interquartile range. To understand interquartile range, you also have to understand quartiles. What are quartiles? So quartiles are values that divide a data set into 4 equal parts, and in these 4 equal parts, each part contains approximately 25% of the data. So if this is your entire data set, then we are just trying to divide this data into 4 equal parts, and these 4 equal parts, they each contain 25% of the data set. Okay, and also interquartile range is a very essential statistical metric for understanding the distribution and the variability of the data. So in this case, this is called quartile 1, this is called quartile 2, this is called quartile 3, or this is called the first quartile, this is the second quartile, and this is the third quartile. So the first quartile is the value below which 25% of the data points falls. So this is the first quartile. Okay, and the second quartile is the data point below which 50% of the data set falls. So this is 50% of the half of the data set. So this is our quartile 2. This is Q2. This is Q1. Q2 is also called the median of the data set. Q2 is also the median of the data set, and this is Q3. You must have understood by now that below Q3 there is like 75% of the data set falls under Q3. Okay, so this is also called the 75th percentile, right? So if you have ever wrote the CAT exam, the CAT exam for the MBA admissions, the score is measured in percentiles, like 98 percentile or 99 percentile, right? This is not equal to percentage. This is not equal to percentage. This is not equal to percentage, okay? Because percentile, so when you say 98 percentile, when you say someone scored 98 percentile in the CAT exam, that means that person has scored more numbers than 98% of the students in the CAT exam. Someone who scored 99.9 percentile in the CAT exam and got an admission to IIM Ahmedabad, that means that person has scored more than 99.9% of the students in the CAT exam. Okay, so that is how percentile works. Okay, let's see how to calculate quartiles. Okay, so to calculate quartiles, the first step is, the step 1 is arrange the data in ascending order. In ascending order. Then step 2 is find Q2 or the median. To calculate the Q2 median, we already know that if the data set has even number of points, then the median is the average of the middle value. For even number of points, the median is the average of the middle two values, and for odd number of points, the median is the middle point. Then step 3, let's find the first quartile, which is Q1. Okay, so in this case, Q1 is the median of the lower half of the data set. So what we did first, we took the data set, we arranged it in ascending order, then we found the median. Once you found the median, that's the second quartile, Q2. Now your data set is divided into two halves. This is the first half and this is the second half. Now your Q1 will be the median of the first half. So this will be your Q1. Okay, so once you get the data points for the Q1, once you get half of your data points, then you have to calculate the median of those data points. So let's say you have like a data set 2, 5, 5, 3, 4, 3, 3, 9, 7, 8, 8, 9. Okay, now first we have to arrange this data set in ascending order. So there goes 2, then we have 1, 2, 3 3s, so 3, 3, 3, then we have a 4, we have 2 5s, and then we have 1 7, we have 2 8s, we have 9 and 9. So we have 12 data points here, and these two are our middle data points. So the average of these points are 5. So this is our Q2. Now our first half of data is 2, 3, 3, 3, 4 and 5, and the second half is 5, 7, 8, 8, 9 and 9. In this case, our median of the first half would be average of 3 and 3, which is 3. So this is our Q1. Okay, so this is our Q1. And then in this case, this is our Q2. This is how we calculate quartiles. This is how we can calculate Q1, Q2 and Q3, first quartile, second quartile, and third quartile. So so finally, quartiles are essential statistical measures for understanding the spread and distribution of data. Quartiles also divide the data into 4 equal parts, and each part contains approximately 25% of the data, providing insights into the position and variability of the observations within the data set. Now there is another very important concept in statistics is outliers. What is an outlier? Outliers. We need to understand what outliers are. So basically outlier is, let's say there is a data set 1, 2, 3, 4, 5, 2, 3, 2, 3, 4, 5, 1, 2. Okay. In this data set, let's say I add another value 102. Now look at these values and look at this one. This one is very odd, right? Now if this data set represents the age of kids, right, and if this data set says age of kids, and if somebody put like a 102, this is definitely an outlier, right? So an outlier is basically a data point that significantly differ from the majority of the observation. So majority of the observation here lies between 1 to 5, and this one significantly differs from the majority of the observations in this data set, and because of that this outlier can skew the statistical analysis and distort the interpretation of this data set if not properly identified and addressed. So if you make a mistake in identifying, because in this case this is very obvious, this is a very simple example, this is not a very proper example, but in a real world scenario, if you make a mistake, if you make an error in identifying correctly an outlier, then that can give a very wrong interpretation of your that can give you a very wrong interpretation of the data set. For example, let's say there is a university, and this university gives MBA programs. Now after completing the MBA programs, let's say there are 5 students that graduate from this MBA program, right? So let's say they get placements from the university. So let's say somebody gets like 10 lakhs, somebody gets 12 lakhs, someone gets 15 lakhs, someone gets 11 lakhs, and then let's say someone gets 50 lakhs, right? So the average of these 5 students is how much? So the average would be 98 lakhs divided by 5, which is 19 point some lakhs. Okay. So in this case, what is happening that the college can go and publish that our average salary in our MBA program is 19.5 lakhs. But the fact is nobody is getting 19.5 lakhs, right? So this 50 lakh salary is drawing your average. So let's say this is our value. So let's say this is our 10 lakhs, this is 12 lakhs, this is 15 lakhs, this is 11 lakh. Let's say this is 50 lakhs, right? So this outlier value is pulling your average towards the right. So it's creating a skewness in your data set, right? So this is what an outlier does. It is an odd data points. It is an odd data point in your whole data set. So basically, let's take another example. Let's say there is a place where there are like small houses, right? Let's say there is a house, let's say there is a little big house, let's say there is a 2-story house. Okay, let's say this is a village, this is a house, let's say this is some different house. Okay, now suddenly some builder comes in and they decided to build like a skyscraper in that village. So this building will be a outlier. This is not normal in this case. Okay, so this is what a outlier is. So an outliers are observations that lie outside the overall pattern of a data set. And what is the impact? The outliers, they can influence the measure of central tendency. Because in this case, in this example, if we take the average of this first 4 data set, it would come somewhere here. Right? But just because this value is present in the data set, the outlier because of the outlier, the mean value is going towards the right. So it is influencing the measure of central tendency and dispersion or range. In this case, for these data points, the range would be 5. But once you introduce the 50 lakhs, the range is 40 lakhs. Right? So it is giving you a wrong interpretation of the data. And what causes these kind of outliers? It could be anything. It could be a measurement error, or it could be a natural variability or anomaly in the data set. So the more we dive deep into data analysis, data science in this channel, we will see like how to handle or how to address outliers in data analysis, or how to deal with this kind of stuff. Okay. So there are different methods we can use to define or to identify outliers. So the one way we can do it like box plots. The second way we can do is like a scatter plot. There is another way we can do it. We can identify a outlier is by using the Z-score method. Okay, and there is another one. There is a modified Z-score method. Okay, and there is IQR method or interquartile range method. There are like some advanced techniques as well. For example, mean absolute deviation or MAD. So this is called MAD, which is mean absolute deviation. Or there is like an advanced technique in machine learning which is called DB-scan. So DB-scan stands for density based spatial clustering of applications with noise. This is something very advanced level in machine learning, so we don't have to break our brain right now, but it's just something that I thought of sharing with you guys, so that you just know something cool today. Okay. So for example, in a box plot, you must have seen, if you looked at like stock prices, you must have seen this is how a box plot looks like. Okay, so that means this is the minimum value, this is the maximum value, this is Q1, this is Q2, and this is Q3. So let's say we have stock prices for a 5-minute window. Okay, so in this 5 minute, let's say the stock went up to 100 rupees, 101 rupees, 102, 101.505, 102.5, like that. Let's say this is the graph. Let's say this is let's say this is your time and this is your price. Let's say in this case, let's say the beginning, the starting time is 10 a.m. and let's say this is 10 and 5 minutes, 10 a.m. and 5 minutes. Okay, so in this case, let's say the stock price went up to 102. Let's say the stock price went like this. Okay, so for the data point, the data of this 5 minute can be represented in a box plot. So in this case, the minimum value is this. So this is the minimum value. This is your Q1, this is your Q2, this is your Q3, this is your maximum value in this 5 minutes. So if you want to see the data for 15 minutes, you just have to build like 3 box plots. Okay, like this. You must have seen box plots like that if you ever try to do like stock trading, or if you look at like financial data, like capital markets and all that. You must have seen like this is called box plot. So in this case, so in a box plot, if a data point is placed, so let's say this is your box plot. So let's say this is your box plot, and no, okay. So how we can identify an outlier using a box plot? Okay, so let's say this is how my box plot looks like. Okay, now this is my q1, this is q2 and q3. Now let's say my interquartile range here is like 10, but if I have a data point that is beyond 1.5 times of the IQR, so IQR is 10, IQR is 10. Now if the data point here is, let's say, below like 15, so let's say this is whatever, minus 15 or whatever, then this data point is a outlier. Or we can use a scatter plot. So a scatter plot is, let's say this is a scatter plot, so you have x, you have y. So if I take different data points here, okay, now if so we can say this is in a book, this is the number of pages and this is the weight of the book. Now let's say suddenly you see a data point which is here, higher number of pages and high weight. This is an outlier. Okay, or if you see a data point here, or if you see a data point here, this is an outlier because the number of pages is low and but the weight is high. So maybe the book is using like very heavy covers or heavy binding, or there could be anything, you know, in the book. So this is what a outlier is. And the statistical method and the interquartile range and everything, we need to we will understand them as we proceed further in this course. Okay, so this is like an introduction to very basic statistics. I hope you liked it. So this is like a very basic introduction of quantitative analysis or like descriptive analysis. I hope you liked it. Let me know your thoughts in the comment box. Thank you for watching.